In this video, I will teach you chapter 4, vector spaces. So what is a vector? Vector is a quantity that has magnitude and direction. Next, you need to know vector in Rn. So what is the vector in Rn? R here represent real number. And N here represent the dimension. So that means it can be R1, R2, R3, and so on until Rn. So R2 means that vectors with 2 entries. R3 means that vector with 3 entries. And so on until Rn, that means vector in n entries. Okay, for example, let U is a vector in R2. So how we represent U in vector R2? So we use the notation for the vector. You can use U as a bold or you can put arrow. Okay, so equal to. So R2 means that U here have 2 entries. So you can write as U1, U2. So we have 2 entries here. Okay, how about U here is a vector in R3. So you write the same thing. You can use the notation U and you put the arrow above the U equal to. So you have 3 entries here. 1, 2, 3. U1, U2, U3. And let's say now U is a vector in Rn. So means that we have n entries here. So you write U here equal to U1, U2 until Un. This one of the way you can represent a vector. Or you can write vector in form of column vector. Okay, let's say here in R2, okay, you can write U1, U2. Okay, we write as a column vector. So for R3, U1, U2, U3, and for Rn, U1, U2, and so on until Un. So you have 2 ways to represent the vector. Okay, you can use this one or you can use column vector. Next, basic operations on vector. So we have 2 basic operations. Okay, first one, addition or subtraction. Okay, so for example, you have U here, vector U here, U1, U2, and vector V, V1, V2. Okay, so how you add or you subtract these 2 vectors? Okay, let's say U, vector U plus vector V. So we have U here, U1, U2, and plus V. So vector V here we have V1, V2. So how you add these 2 vectors? Okay, the first entries in this element you add with the first entry in the second element. So that means U1 plus V1. Same thing here. The element in the second entries here, you add with the element in the second entries for vector v. So you will have here u2 plus v2. How about subtraction? Okay, so it means that vector you minus with vector v. So same thing, you write first what is vector u, and then we minus with the vector v. So same thing here, the first element here, you minus with the first element in the vector v. So u1 minus v1, and then for the second element here, u2 minus v2. That's how you do it, addition and scalar multiplication. The given example here, I use vector u and v in R2, but it apply the same thing for the vector in R3 or in Rn. Second operation is scalar multiplication. Same thing here, let u vector in R2, and we have k here. Okay, k here be any scalar. Alright, that's mean be any number. So scalar multiplication means that we multiply scalar with the vector. So means that if you can write it here, k here, you multiply with the vector u. So first, you substitute what is the vector u first. So u equal to u1, u2. So how you do the scalar multiplication here? So k here you multiply with the u1, and k here you also multiply with the u2. So that's how you do it, the scalar multiplication. Scalar here you multiply with all the element inside the vector u. Let's try example page number 66. Okay, consider the vectors a and b. Alright, so vectors a and b here in R3 because we have 3 elements in a and also 3 elements in b. So first one, show that a is parallel to b. So the words parallel. So you can refer your textbook, page number 66, okay, to solve this kind of question. Alright, so if you can read here, let u and v be 2 vectors in R2 or R3. So 2 vectors u and v are said to be parallel. Okay, you can see the word parallel here, to each other if u is a scalar multiple of v. So means that when you want to show 2 vector parallel or not, you need to show that this 2 vector is a scalar multiple of one another. So you can write in this form, u equal to cv, where c is a scalar. Okay, based on the information we have from this one, so we try to solve this one. Okay, is it a and b here parallel or not? So we start from this one. Okay, is it a equal to cb? So we need to find such c here so that a is scalar multiple of b. So if a is scalar multiple of b, we can say that a and b are parallel. So we substitute a. Alright, vector a here is 1, -2, 3 equal to, okay, so c here, we want to find c here, and then you substitute vector b, -2, 4, -6. So we do the formulation here. So you multiply c in each entries. Right, so you have here -2c, 4c, and -6c. So next we do the comparison. Okay, the first element here you compare with the first element on your right. So the second element on your left here you compare with the second element on your right here, and the third element on your left here you compare with the third element in your right here. So we take the first element here. So we have here 1 here equal to negative 2c. So next we solve for c. So you get here c equal to negative 1 over 2. Alright, so now we try to solve the second element here. So we have here 4c equal to negative 2, or you can write negative 2 equal to 4c. Alright, so you solve for c here, c equal to negative 2 over 4. So you get here c equal to negative 1 over 2. Okay, next, third element here, negative 6c equal to 3. So same thing, you solve for c here, you get here 3 over negative 6. So equal to negative 1 over 2. You can see it here. All the value of c here equal. Negative half, negative half, negative half. Means that you can write it here. A here actually is a scalar multiple of b. Because we can find such c here. So that we can write in this form. So from this one, we can conclude that vectors A and B are parallel. Second question, is A in the same direction or in the opposite direction to B? Give your reason. Okay, so to solve this question, okay, you can read also from the information from your textbook, okay, the same page, page number 66. Alright, if the value of c here that we get is positive or greater than 0, means that these two vectors have the same direction. But if you get the value of c here is negative or less than 0, these two vectors have opposite direction. Now we can answer this question. Alright, since the value of c here that we get is negative 1 over 2. So means that less than 0. So if c here less than 0, means that these two vectors have opposite direction. Or in the opposite direction. That's how you determine these two vectors are in the same direction or in the opposite direction by value of c here. So as your practice, try to solve exercise, okay, page number 66. Next, we try to solve example page number 69. So you are given two vectors v and x. So v and x here, vectors in R3. So A, find the magnitude of v. So to solve this question or to find the magnitude of v, so please refer your textbook, okay, page number 68. Alright, so here about length and magnitude of vector. So let's say here we have two vectors u and v. U here in R2 and v here in R3. So how we find the magnitude or length for these two vectors? So simple. Okay, so the magnitude here we use this notation. Alright, to denote as a magnitude. Alright, So for u here, so you take the element here, u1 here, u square, and then you plus with the second element, okay, u square. Then you put the square root. Okay, same thing for the vector v here in R3. So magnitude of v here, v1 square plus v2 square plus v3 square, and then u square root. So now we can find the magnitude of v. So we use this notation to represent the magnitude. So this one, our vector v. So to find the magnitude, okay, each element in v, we put square. So u2 square plus -1 square plus 3 square, and don't forget to put the square root here. Okay, so we can solve this one. So 2 power of 2, 4 plus 1 plus 9. So what you will get here? Square root of 14. That's how we solve, or that's how we find the magnitude of a vector. Next, B. Right, find the vector P. Okay, so means that we need to find the vector P here that is in the opposite direction to V. Alright, so P here is a vector in the opposite direction to vector V. Right? So V is given here. So given here, the magnitude of P equal to square root 14. So to solve this question, you refer your textbook, page number 68. Okay, under the subtopic direction vector. So this formula you will use to solve B here. So if you can read here, vector W, okay, this one means that you want to find the vector W here in the same direction. Okay, the first one, same direction of vector Z. So the formula will be W equal to positive. Same direction, positive here. So magnitude of W, you divide with the magnitude of Z, and then you multiply with the vector Z. But if W in the opposite direction to Z, so we put negative. So W equal to negative, magnitude of W, you divide with the magnitude of Z, and then we multiply with the Z. So the difference here is positive for the same direction and negative for the opposite direction. Now we can solve for the vector P. So how you can find P here? So vector P here equal to negative. Alright, because P here in the opposite direction. So you put negative. Alright, so the formula will be the magnitude of P here. You divide with the magnitude of V here. And then we multiply with the vector V. Alright, so magnitude of P here is square root 14. Okay, what is the magnitude of V? Alright, you can get from A here also square root 14. And then we multiply with the vector V. So vector V is 2, -1, 3. Okay, so now we can solve for this one. So square root 14 divided by the square root 14, you will get here -1. And then we multiply with 2, -1, 3. So what you will get for the vector P? So P here equal to -2. Alright, you multiply -1 in each element inside the vector V here. So -2, 1, -3. So now you get the direction vector P. Okay, C, find the unit vector. Okay, the keyword here is unit vector. So find the unit vector u in the direction of x. So to find the unit vector, so please refer your notes in your textbook, page number 69. Alright, so what is a unit vector? So a unit vector is a vector of length 1 or magnitude equal to 1. So we have two formula here. Okay, let's say we have two vector here, u and v. So a unit vector u, so means that u here is a unit vector, right, in the same direction of v. So you want to find u, so u equal to, say, because in the same direction, so positive. Alright, so vector v, you divide with the magnitude of the vector v. But if u in the opposite direction of v, so you just put negative, right? So this one, the formula to find a unit vector. So remember, a unit vector is a vector of length or magnitude is 1. Then we can solve C. Find the unit vector u in the direction of x. Okay, in the direction of x means that same direction. Okay, if the question didn't mention opposite, means that in the same direction. But if in the opposite direction, sure, the question will write it as a opposite direction. But if the question didn't mention opposite or same, means that in the same direction. Okay, so see here, in the same direction of x. So u here equal to vector x, you divide with the magnitude of the vector x. Right, so vector x equal to 1, 0, 2. So we find the magnitude of x. So magnitude of x equal to, okay, so 1 square plus 0 square plus 2 square. And remember to put the square root here. So we can solve for the magnitude of x first. So what you will get here? 1 plus 0 plus 4. So means that you will get square root of 5. So now you can solve. Okay, so 1 here you divide with this one. Or actually, you can put it as a scalar multiplication. Okay, and then we can solve for this one. 1 over square root of 5, you multiply in each element here. Okay, so 1 over square root of 5. So this one 0. This one 2 over square root of 5. So you get the unit vector of u. Same thing here as your practice. I want you to solve and try exercise page number 69. Okay, next we solve example page number 71. Okay, the question give two vector, right, u and v, and find the angle between vectors u and v, and then state type of angle. Okay, so means that you need to find the angle. So to find the angle between two vectors, okay, please refer your textbook page number 70. Right, so the angle between two vectors is given by, right, theta here. So theta here represent the angle. So theta equal to arc cos. Alright, so u dot v, you divide with the magnitude of u, multiply with the magnitude of v. So the angle here between 0 to pi. So next, you need to know what is the dot product here. Because you can see here, u dot v. So I will explain it to you how to find the dot product between two vectors. Before we proceed to solve example page number 71, let's learn about dot product. Okay, dot product is one of the operation on vectors. So let's say you have two vectors, alright. So here vectors in R3, alright. So you have u and v. So to find the dot product between u and v, so u dot v. So we use the dot here. You can see the dot here as a notation to represent the dot product. So the dot product between u and v, alright, this one the vector u, alright, and this one the vector v. So to solve the dot product here, so what you need to do, u1 you multiply with v1. Okay, so u1 v1 plus you multiply u2 with v2. So u2 v2 and then you plus with u3 you multiply with v3. So you will get here u1 v1 plus u2 v2 plus u3 v3. So when you solve this one, you will get a scalar or a number. That means the dot product will give you a number as an answer. Okay, then we solve the example page number 71. So we need to find the angle. So the angle here is theta. So the formula will be arc cos u dot v. You divide with the magnitude of u. And then we multiply with the magnitude of v. Okay. So this one the formula to find the angle between two vectors. So this one between vector u and v. Okay, next step, we compute the dot product first. Okay, so we find u dot v. So equal to, so the vector u is 2, 1, negative 2, dot with the vector v and v1, negative 3, 6. Okay, so we solve the dot product here. So u dot v, so how we solve this one? So 2 here multiply with 1. So 2 multiply with 1 plus 1 multiply with negative 3. Okay, so 1 multiply with negative 3. And then plus, okay, the third element, negative 2, you multiply with the third element in this vector, so 6. And then we solve this one, so 2 minus 3 minus 12. So the dot product between u and v here equal to negative 13. Okay, next, we find the magnitude of u. Alright, so the magnitude of u equal to, so 2 square plus 1 square plus negative 2 square. So we put the square root here. So we solve the magnitude of u first. So 4 plus 1 plus 4. So you will get here square root of 9. So square root of 9 equal to 3. Then we find magnitude of v. Alright. So the vector v here. So 1 square plus negative 3 square plus 6 square. So we put the square root here. So we solve for this one. So 1 plus 9 plus 36. Okay, so square root. So you will get here square root of 46. So we get the all the information to find the angle here. Then next, we substitute into the theta here. Then we can get the angle. Alright, so we can compute the angle between U and V. So at cos, okay, so here, refer to the formula here, U dot V. So U dot V equal to negative 13. And then we divide with the magnitude of U multiply with magnitude of V. So magnitude of U is 3. Multiply with the magnitude of V is square root 46. So you can solve now using your calculator. Alright, so you will get the answer as 129.71 degree. Okay, so you get the angle between U and V. So next question, we need to state the type of angle. Alright, so to know the type of angle, so please refer your textbook or your notes, page number 70. So you can see here types of angle. So you have 3 types of angle. Okay, first one, acute angle. Acute angle means that your theta here between 0 to pi over 2. Pi over 2 here equal to 90 degree. Or if you dot product between U and V, you get greater than 0 or positive. Okay, the second, obtuse angle. Obtuse angle, the theta here between pi over 2 to pi. Okay, so means that between 90 to 180 degree. Or if you dot product U dot V, you get less than 0. Okay, or negative. Alright, this one positive. Alright, so the third angle is right angle. So right angles means that theta here equal to pi over 2 or 90 degree. Exactly 90 degree. So for this one, you dot product U dot V here, you get exactly 0. So for this one, you can show that U and V here are orthogonal. If you dot product, you get 0. Alright, so for the third one here, you can use to show that the angle between two vectors orthogonal or not. Then we can solve for this one. So since theta here, alright, we get greater than 90 degree, right? Or theta here, you get between 90 to 180 degree. Okay, so you get 129.71 degree. So between this one. Okay, so this one means that the second angle here. So second angle here is obtuse angle. So hence it is an obtuse angle. Okay, or you can check from the dot product. Okay, so the dot product, you get less than 0 or negative, right? Just now, negative 13. So means that the angle that we get here is obtuse angle. Okay, let me show it to you how to solve exercise page number 71. Okay, for A and B. But for C, okay, you try to solve it on your own. Alright, so given here, vectors A, B, and C. So A here, you need to find the vector D here such that D here equal to B minus 2C. So first we substitute vector B here, alright, 1, 0, negative 3, and then minus 2 multiply with vector C. So C here 3, 6, negative 3. So next step here, so we do the scalar multiplication for this part. So 2 here you multiply with all the element. inside this vector. So 2 multiplied with 3, you get 6. 2 multiplied with 6, you get 12. And 2 multiplied with negative 3, you get here negative 6. And then we solve the subtraction here. Alright. So you subtract here first element with the first element on the second vector. So 1 minus 6. Okay, the second element in the first vector with the second element on the second vector. So 0 minus 12. And the third element with the third element in the third. The third element here with the third element in the second vector. Okay. So then 1 minus 6, you will get here negative 5. So negative 12. And this one you will get here negative 3 plus 6. So you will get here 3. So now you solve for D. Okay, for B, show that vector A is orthogonal to C. So for this one, how you show that a vector or two vectors are orthogonal? So remember, I just said just now, if you want to show two vectors are orthogonal or not, you use the dot product. So now you find the dot product between vector A with vector C. Okay, so we find the dot product for these two vectors. So A is 4, negative 1, 2, and dot with the vector C is 3, 6, negative 3. So remember how to find the dot product. So 4 here, okay, the first element in the first vector, you multiply with the first element in the second vector. So 4 multiplied with 3, and then you plus second element here. Okay, in the first vector, you multiply with the second element in the second vector. So negative 1 multiplied with 6 plus, okay, the third element in the first vector here, you multiply with the third element in the second vector. So 2 multiplied with negative 3. So you get here 12 minus 6 and then minus 6. So you will get here what? 0. So then we can conclude that, alright, since the dot product between vectors A and C equal to 0, then vector A is orthogonal to C. So remember here, when you want to show two vectors are orthogonal, you use the dot product. Okay, if you get 0, means that the two vectors are orthogonal, or sometimes we call it perpendicular, or we also can call it as a normal. Okay, that's how we solve for A and B. Okay, so for you as your task, you try to solve C, and also try to solve, okay, homework 4.1 here. Okay, as your practice, try to solve all the question in homework 4.1. Okay, that's all. Thank you.